Question 15. Jenny's asked to find the value of 12 minus 2 times 4. Here is working. 12 minus 2 times 4 equals 10 times 4 equals 40. Jenny's answer is wrong. Explain what Jenny has done wrong. Well, this is the rules of BODMAS or BIDMAS, depending which way you've learnt this. It tells us the order of operations. So you have to explain what Jenny's done wrong, not just give the right answer. Okay, so in this instance, what's Jenny done wrong? Well, it looks like she's done 12 minus 2 is 10, and then times that by 4. But BODMAS says we must do the multiplication first. Okay, so Jenny hasn't multiplied first. For an arrow to see what it would mean, okay, it's 12 subtract, but we should have done 2 times 4 first. Okay, that would give us 12 minus 2 times 4, which is 8, giving us the correct answer is 4. So that would give us a full mark there. Rehan is asked to find the range of the numbers. Here is his working. 5 minus 3 equals 2. We know the range is the largest number minus the smallest number. And it looks like he's just taken the 3 from the 5 because they're either ends of the list. Okay, this is wrong. He has not worked out largest minus smallest. Should be 8 minus 1, which gives us 7. You don't need this bit here, but it shows that you've fully understood what's going on. Question 16. Bit of information here to get phased about. We just have to read this carefully. Alan, Bispa and Chan share a sum of money. Alan gets 1/8. Bispa gets a half of the money and Chan gets the rest of the money. Well, and it says Alan gets £2.50. Work out how much money Bispa gets. Well, we've got a bit of linked information here. If you look at it, the £2.50 is what Alan gets, is 1/8. So if I draw a little diagram to represent that, we'll use a little bar diagram here. Okay, Alan gets 1/8, so let's just check. 1, 2, 3, 4, 5, 6, 7, 8. So Alan gets that one. Alan. And we know that that's £2.50. If we know that's £2.50, all of these must be £2.50. Yeah, each one of these would be £2.50. I can't write it in there, but you can see that. How many are there? There's 8. So the total must be 8 lots of £2.50, which is, in your calculator, or if you know this, probably just check on the calculator, it's £20. So that's the total amount altogether. And we're told Bispa gets half the money. So half of 20 is simply £10. Part B. Find the ratio of the money Alan gets to the amount of money Chan gets. Well, we've got Alan. We know Alan gets £2.50. £2.50. Chan must have the rest. So Chan, well, how do we work out what Chan's going to get? There's £20 altogether. Chan gets the £20 minus Alan's share minus Bispa's share. So I think that works out £7.50 if you work that out. So Alan to Chan, in our ratio, Alan to Chan must be £2.50 to £7.50, sorry, if we do it in money. So let's read the question again now. That's a ratio. That would give us one of those marks. Give your answer in the form A to B, where A and B are whole numbers. What A to B means is just two numbers where they're whole numbers. Now, easiest way to do this would be look at this, and actually if you double both these now, you will get 5 to 15. That would be acceptable. Some of you out there will look at it and go, actually, but that can be simplified. If I divide both of them by 5, I get 1 to 3. But either of these two are acceptable as answers. Question 17. The area of the triangle is 162 centimetres squared, and it's a right angle triangle, isosceles right angle triangle. Isosceles, and we can see that because that's 3x and that's 3x as well. Right angle might make you think of Pythagoras, but it's not to do with Pythagoras or trigonometry here because it's talking about the area. So what's the area of that triangle? Well, we've got the area we know is 162. What would it be in algebra? Okay, so area is 162. That's the numerical number for it. If we look at algebra, that would be base 3x times height 3x divided by 2. Okay, so that gives us 9x squared over 2. So what we can actually do now is make an equation from this, because we now know that 162 must be equal to 9x squared over 2. What's stopping x squared be on its own? The 9 and the 2. We're going to times by 2 first. So 9x squared, let's just show this here, times by 2, times by 2. 9x squared is 2 times x squared, then it would be 2 times 162, which is 324, I think. Now we've got to divide by 9 to get rid of that 9. There's 2 times in the x squared. So 324 divided by 9 gives us 36. And finally, square root both sides. And that gives x is the square root of 36, which we probably know that is 6. So the answer is x equals 6. Next question. We probably do this on a calculator. That means 2.645 times 10 to the power of 9 divided by 1.15 times 10 to the power of 3. We put it in our calculator using our standard form button. You should all have something like that. So if I put that in then, so we can get this to C, 2.645, just cancel that. 2.645. You don't need to press the times button here, you just have to press this button here now, times 10 to the power of, let's show how that shows up on the screen there, times 10 to the power of 9, divided by 1.15, again, times 10 to the power of 3, equals now, and we get this number here, which is 2, 3, and 1, 2, 3, 4, 5 zeros. So equals 2, 3, and 1, 2, 3, 4, 5 zeros. And now we have to change that into standard form. So to do that, the number between 1 and 10 we're going to get is 2.3. How many places do I need to move the 2 to get it in the right position? Well, I need to move it over 1, 2, 3, 4, 5, 6. So it's times 10 to the power of 6. And that's our answer. 2.3 times 10 to the power of 6. I want to read this carefully now. Scatter diagram shows information about 12 girls. It shows the age of each girl and the best time she takes to run 100 meters. Write down the type of correlation. Well, hopefully you'd be dying to draw on a line of best fit here, which you can do with a ruler, which we'll do in at the moment. You can see that the crosses are all going in this sort of direction, from top left to bottom right. So as age is increasing, time is decreasing, and we know that if crosses go in this sort of pattern, that is a negative correlation. I'm just going to draw on the line of best fit now just to see what's happening here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So really get that sort of angle where the crosses are going. And because there's 12 crosses, I'm going to move this now until I've covered 6 crosses. I'm going to start here. So 1, 2, 3, 4, 5, 6. So somewhere around there would be sort of line of best fit that I would use there. Okay, just check that again. 1, 2, 3, 4, 5, 6. 1, 3, 4, 5, 6. About 6 on each side and go in the right direction. We may need it, we may not need it, but the point is I've got it there now. Okay, the next part says Christina is 11 years old. Her best time to run the 100 metres is 12 seconds. Let's put that on the diagram. 100 metres in 12 seconds. 100 metres in 12 seconds, and she's 11 years old. So 11 years old, 12 seconds. So this is Christina. What does it ask us now? It asks us, the point representing this information would be an outlier on the scatter diagram. Explain why. Well, I think we can see this. Her point does not follow the trend of the other crosses. Okay, so that would be a good one way of explaining it. Her point does not follow the trend or pattern, you could use the word pattern, of the other crosses. Okay, that's perfectly fine. You might have also written her point is far away from the line of best fit, so we can use that. Okay, so it's 2 ways of saying that. Debbie is 15 years old. Debbie says the scatter diagram shows I should take less than 12 seconds to run 100 metres. Comment on what she says. If you look at the diagram now, Debbie's 15. Well, I suppose you can see why she's saying that, but what we've got to look at here is our data is only valid between the cross for the highest age group, which is just under 14 years old, and the lowest age is just under 10. So really, we can only predict accurately using this line here. We can only predict accurately between people from 10 to 14 years old. So we'd say this is unreliable as we can only make predictions for 10 to 14-year-olds. Excellent. Right, moving on. Question 20. Question 20, expand and simplify. Okay, now you'll notice you've got 2 brackets here. My tip with this is to cover up one and multiply the first one. So, a bit hard to do. I'm going to cover up my ruler. Cover it up, okay, and multiply the first bracket out. So 5 times p is 5p. 5 times positive 3 is plus 15. Move the ruler to the other one and cover up. Now be careful, if you cover up now, 2 doesn't have a sign, so make sure you've got the sign for 2 there, which is negative this time. So negative 2 times 1 is negative 2. Negative 2 times negative 2p, well a negative times a negative is a positive, and 2 times 2p is 4p. Okay, that's the first part done. Now we have to simplify, so gather like terms. There's a 5p plus a 4p, which gives us a 9p. And we've got a 15 subtracted 2, which gives us a positive 13. And so that's the answer. 9p plus 13. Question 21. Here is a trapezium drawn on a centimetre grid. So this means that each square is 1 centimetre by 1 centimetre. What does the question want us to do? On the grid, draw a triangle equal to area of this trapezium. So we're having to find the area of this trapezium. Now, these are the parallel sides. I'm just going to mark these on. And there is a formula for this, but it's probably best remembered by working out half the sum of the parallel sides and times the distance between them. So the sum of the parallel sides, well, we've got 2 squares long that side, and this one's 1, 2, 3, 4, 5, 6, 7. And the distance between the two parallel lines, we can measure here, is 4 squares. So I've got everything I need now for the area of that trapezium. So the area is equal to half the sum of the parallel sides. What does that mean? That means add the parallel sides, half the sum. Okay, so 9 divided by 2 equals 4.5. And we take that answer times the distance between them. So it's 4.5 times 4, which gives us 18 centimetres squared. You can see that over there. If you're good with the formula, you could have done it by working out, just going 2 plus 7 divided by 2, half the sum of the parallel sides, times 4. So that still becomes 4.5 times 4, and we still get 18. Quite good for a calculator there. So we need an area of 18 centimetres squared for a triangle. Now we know for a triangle, the area of a triangle is base times height divided by 2. We want that to be 18. So, okay, so if base times height divided by 2 is 18, has to be equal to 18. That must mean that the base times height must be equal to 36. Okay, so if we have to divide that by 2 to get to 18, that's what we're going to get. So numbers that make 36 easily away, you could use 3 and 12, couldn't you? Or 6 and 6, or 4 and 9. Lots of different ones you could draw. I'm going to go for a nice right angle triangle that is 6 by 6. I'm going to start here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there we have it. That triangle has exactly the same area. Okay, so it's exactly the same triangle you're going to get there. 18. 6 times 6 divided by 2. You could also have done 6 and add a height. You could have done the height anywhere as 6. 1, 2, 3, 4, 5, 6. I could have drawn a triangle with 6 of the base. This triangle also has a height of 6. You can see there are 6 units, but so there's more than one choice there, but those are probably two most common. Question 22 is a probability question on tree diagrams. When a biased six-sided dice is thrown once, the probability it lands on a 4 will be 0.65. Well, it's biased because normally the probability of it landing on any number would be 1 out of 6 chance, which is about 0.16. Okay, so that's why it's biased. We've got more chance of landing on a 4. Amir draws this probability tree diagram. The diagram is not correct. Let's have a look. Probability of landing on a 4 is 0.65, that's correct. But that means the probability of not landing on 4, well, that's definitely not right, is it? Because these two should add up to 100%, or 1, if it's as a decimal. So it says write down two things that are wrong. We could say 0.65 plus 0.25 do not equal 1. So the probability of not land 4 on 4 should be 0.35. And we look at the second branch to see what's wrong here. Probably landing on 4, 0.65, 0.3, that looks okay. Doesn't it? That looks okay. Let's check this one. Probably it lands on a 4, 0.35 and 0.65. Well, that's been mixed up, hasn't it? Okay. So the second thing that's wrong, 0.65 and 0.35 have been swapped in the second throw. And you know, a good idea here is just take this information and just show what you're talking about here. Okay, so I'll put a little arrow to show that I'm referring to what it is, because otherwise words can sometimes get misunderstood. And that's it for that one. 23. Right angle triangle. is working out an angle. So this is either Pythagoras or trigonometry. Because we're asked to find an angle, it's going to be trigonometry. So we write down, what do we know? Well, we know 7 centimetres. That looks like the adjacent. The hypotenuse we know because it's the longest side. The right angle is pointing towards it. And the angle is equal to, let's just call it x for now. And which of those is it? Well, adjacent and hypotenuse. It's not that one. K has got adjacent and hypotenuse, isn't it? So writing it down, cosine of the angle is equal to adjacent over hypotenuse. If you want to write that, cos x equals a dj over hype, and then write in what you know, maybe that helps. Adjacent is 7, and hypotenuse is 11. This is one then we're going to have to undo that cosine function by applying inverse cosine. Okay, so we get inverse cosine of both sides, we're going to have to do. And that will look like this when you put it on the calculator. That'll undo the x there, but that means we have to do the inverse cosine of 7 over 11. Again, on our calculators, let's try and get the right light here. There we are. Oh, nearly. Better there. Okay, so we got, let's turn this on. Shift cosine. Shift cosine. 7, 11. Well, brackets in the wrong position there. Hold on a minute. Just move this arrow key here to move that away if I have a problem with that. Put that second bracket in. And press equals now. It's in the wrong mode at the moment. This sometimes can happen, okay? So let's just try that again. Mode. So different calculator to yours, so hopefully yours will be in the right mode. Okay, I can see here I've got 3 options here. You'll have a D, an R and a G. You should always be in D. And I'm going to press 1 now to change mine to that, but your calculator will be in that. So let's do it again. So what have we got? We've got shift cos 7, 11, 7 elevenths, move it away, in my bracket. Press equals, and we get 50.47 there. 50.47. It wants to 1 decimal place, so that's going to be 50.5 degrees 1 dp. Then says length of side AB will be reduced by 1 centimetres. Okay, so that means now AB would be equal to 10. Length of BC is still 7. The angle will be 90 degrees. Will the value of cosine ABC? Now, a lot of people think it's talking about the angle sides. Okay, so let's look at this. Cosine ABC, or cosine x in this case. AB is the hypotenuse. This is the adjacent. So now it's going to be 7. It's going to be, instead of being 7 over 11 as it was previously, it's now 7 over 10. And that's what you're comparing now. You're comparing this to this. Okay, so will the cosine be bigger or smaller? Well, 7 divided by 11 or 7 divided by 10. Well, if you had 7 pizzas and you shared it between 11 people, or if I shared it between 10 people, you're going to get more. It's going to be a bigger answer if you've got, or a bigger amount of slice if you've got 7 pizzas divided by 11. So the answer is cosine ABC will increase as 7 over 10 is larger than 7 over 11. And that will do as an answer for that one.